Demographic segmentation analysis in customer analytics. We will learn how to divide customers into groups based on demographic attributes. This helps businesses understand who their key customers are and how needs differ. You will use real-world datasets to uncover patterns by age group, gender, region, and more. Insights can guide marketing, product development, and customer retention strategies. Running the cell now. We import pandas to handle data tables. We import NumPy for fast calculations and grouping operations. We import OpenML to fetch real open datasets for market research. We also import warnings. We suppress warnings to keep our output clear. Running the cell now. Understanding demographic segmentation and the datasets. Demographic segmentation means dividing customers based on attributes such as age, gender, income, region, or education. Real business survey or customer datasets usually include categorical and numeric columns. Columns may represent gender, M or F, age group, region, and responses to satisfaction or NPS questions. Beginners often forget to check for missing data, or may group by the wrong column. Some mistakes include mixing numerical and categorical features in aggregation, or mislabeling demographic buckets. Running the cell now. We download a real customer satisfaction dataset. We load the data into a pandas data frame for analysis. We print the number of rows and columns to see how large the dataset is. We view the first 3 customer records to understand the structure. Running the cell now. This output shows the dataset has 7,043 rows and 20 columns, indicating a sizable customer survey with various features. Key columns like gender, senior citizen, and Churn illustrate demographic and behavioral data used for segmentation and analysis. The preview helps confirm the dataset includes both categorical attributes and numeric values, essential for understanding customer groups and preparing for segmentation. Try running print df.columns to see all available demographic and behavioral variables. To start segmenting, we count the number of customers by gender. We print the result to see if the dataset is balanced. Running the cell now. This output shows the count of customers by gender in the dataset, with males and females nearly evenly represented. Noticing this balance is important for demographic segmentation, as it ensures that any analysis or marketing strategy informed by gender will be based on substantial data from both groups. It also confirms there are no missing or misclassified gender values in the column, which is a crucial step before further grouping and analysis. Which gender is more common in this customer base? We analyze what percentage of customers are senior citizens. This helps identify if the service appeals more to a certain age group. Running the cell now. This output shows the percentage of customers who are senior citizens, value 1, versus non-seniors, value 0, in the dataset. Noticing that around 16% of customers are seniors highlights the demographic distribution, which is key before segmenting or analyzing satisfaction by age group. Checking these proportions ensures the code groups by the correct column and accounts for all categories in demographic segmentation. How might services or marketing differ for senior citizens versus others? Next, we check how many customers have a partner. We print the counts for yes and no. We also count customers with dependents, as this can influence service needs. The output shows both partner and dependent breakdowns. Running the cell now. This output shows the counts of customers grouped by the partner and dependents columns, revealing nearly balanced groups for partners but a larger no group for dependents. Noticing these counts helps ensure the demographic segmentation captures meaningful splits and checks the data has expected categories before further analysis. This step is crucial to avoid grouping by columns with missing or skewed data. What segments might need family-oriented products or special offers? Here we group customers by how long they have been with the company, tenure. We create tenure buckets, less than 1 year, 1 to 3 years, and 3 to 6 years. We count customers in each tenure segment. This helps us see where most loyalty comes from. Running the cell now. This output shows the number of customers segmented into 3 tenure groups based on how long they've been with the company, less than 1 year, 1 to 3 years, and 3 to 6 years. Notice the largest group is the 3 to 6 year segment, indicating many customers have longer relationships. This grouping helps us understand customer distribution over time, which is crucial for analyzing loyalty and targeting retention strategies. How might loyalty offers target these different tenure groups? We analyze churn rates by gender. This table cross-tabulates gender and whether the customer has left, churn equals yes, or stayed, churn equals no. Running the cell now. This output shows the count of churned and non-churned customers segmented by gender, highlighting differences in retention between males and females. Notice that while both genders have similar churn numbers, males have a slightly higher count of non-churned customers. This reinforces the importance of correctly grouping by categorical columns like gender to analyze key customer segments accurately. Which gender has a higher churn rate in this dataset? We calculate the average monthly charges for senior citizens versus non-seniors. This is useful for pricing and customer value analysis. Running the cell now. This output shows the average monthly charges grouped by whether a customer is a senior citizen or not, highlighting a clear difference between the two groups. Notice that senior citizens, 1, tend to have higher monthly charges, 79.82, compared to non-seniors, 0, at 61.85. This underscores the importance of correct grouping in demographic segmentation to uncover meaningful insights about customer behavior. Analyze why average spend might differ by age or life stage. We examine how different contract types relate to churn rate. This shows what percentage of each contract group leaves or stays. Running the cell now. This output shows the percentage of customers who churned or stayed, segmented by their contract type. Notice how churn rates are highest for month-to-month contracts and lowest for 2-year contracts, highlighting a clear trend in customer retention linked to contract length. This helps emphasize the importance of grouping by meaningful categorical columns to reveal actionable demographic patterns. How could contract features be adjusted to improve retention? We create a crosstab to explore senior citizen use of different internet services. This helps with product targeting by demographic. Running the cell now. This output shows a cross-tabulation of internet service types by senior citizen status, revealing how many customers in each group use DSL, fiber optic, or no internet service. Notice the larger counts of fiber optic users in non-seniors versus seniors, highlighting demographic differences in internet adoption. This type of grouping helps identify patterns within customer segments and ensures you're segmenting on the right attribute without missing data. Can you spot which service is more popular among seniors? We segment churn rates by both partner status and dependence. Multi-attribute segmentation uncovers specific risk groups. Running the cell now. This output shows the percentage of customers who churned or stayed, segmented by whether they have a partner and dependence. Notice how having dependents or a partner is associated with lower churn rates, highlighting how demographic groups differ in loyalty. This reinforces the lesson's point about using multiple categorical columns to segment customers meaningfully and checking normalized counts for clearer insights. Why might churn be higher for certain family types? We switch to a real marketing campaign dataset from OpenML. We load the dataset into a data frame. We rename columns to reflect business context. We create age brackets for more granular segmentation. We count customers in each age bracket. This informs targeted campaign design. Running the cell now. This output shows the count of customers segmented into 4 age groups, revealing that the largest group is 36 to 50, followed by 26 to 35. Noticing these counts helps confirm that the age segmentation via PD cut worked correctly and highlights how customer distribution varies across age brackets. This validates the code's intent to create meaningful demographic segments for further analysis. Practice: try segmenting by job or marital status for the same dataset. We create a crosstab of education versus age bracket by campaign response. This blends two demographic axes to find high-response customer segments. Running the cell now. This crosstab shows customer responses segmented by education level and age group, illustrating how satisfaction, responses 1 and 2, varies across these demographics. Notice the clear trend where higher education groups generally have large accounts, especially in the 26 to 35 and 36 to 50 age brackets, highlighting how combining categorical columns helps reveal nuanced patterns in customer data. This underscores the importance of correctly grouping by relevant demographic features to inform targeted marketing or service strategies. Spot the highest performing education and age segments. Now we segment by both job type and customer balance bucket. We calculate response rates within these finer demographic financial segments. This targets marketing spend with real ROI impact. Running the cell now. This output shows the percentage of positive, 1, and negative, 2, responses grouped by job type and categorized account balance, which helps us see how response rates vary across financial segments within job roles. Notice how customers with debt balances tend to have higher positive response rates, highlighting the importance of carefully segmenting by meaningful categories like job and balance to uncover actionable insights in demographic data. This aligns with the lesson's focus on combining categorical and numerical data for precise demographic segmentation. What recommendations can you make for campaign focus as a result? For quality analysis, we should check for missing entries in demographic or segmenting columns. We count missing values in the tenure column. Running the cell now. The output shows there are 0 missing entries in the tenure column, indicating the dataset is complete for this key numeric attribute. This is important because having no missing data ensures reliable demographic segmentation based on customer tenure. Always checking for missing values helps prevent errors in analysis or incorrect groupings later. Always check for missing key fields before segmentation. We verify whether a region column exists before segmenting by region. If available, we print the region distribution. Otherwise, we state it is not present. Running the cell now. This output indicates that the dataset does not contain a region column, which is important for demographic segmentation by location. Noticing this early prevents errors in grouping or analysis and reminds us to always verify that key demographic fields exist before proceeding. This check ensures our segmentation efforts are based on valid, available data. Checking for correct column names prevents errors in groupings. Here we intentionally group by a misnamed column to illustrate a common error. The code will catch and print the error. This reminds us to double-check column names when segmenting. Running the cell now. This output shows a clear error caused by a typo in the column name gender instead of agenda. It highlights the importance of careful spelling when grouping data for demographic segmentation, as even small mistakes can cause your analysis to fail. Always double-check column names before grouping to ensure accurate and meaningful results. Tip: use print df.columns to see correct spellings. To avoid aggregation errors, we check and fill missing values in monthly charges. If missing, we fill with the median. Otherwise, we print that all values are present. Running the cell now. This output confirms that the monthly charges column has no missing values, so no data imputation is needed. This step is crucial in demographic segmentation to ensure complete numeric data for accurate analysis, avoiding errors or biases caused by missing values. Checking for nulls helps maintain data quality before grouping customers by attributes like monthly charges or demographics. Practice: check other numeric columns for missing values. If NPS, Net Promoter Score, is not present, avoid mapping random columns. We use Churn as a loyalty proxy, with no churner as loyal. Print % of customers considered loyal in this dataset. Running the cell now. This output shows that approximately 73.46% of customers are considered satisfied or loyal based on the proxy variable, the churn being no. Notice how the code uses a simple condition to estimate customer loyalty from churn data, highlighting the importance of carefully interpreting available columns as proxies when explicit NPS or satisfaction scores are missing. This step underscores a common beginner pitfall, assuming a direct metric exists without verifying the relevance or completeness of the data. Confirm that proxies are conceptually appropriate before using. Best practice: use cross-tabulation to compare two demographic axes. This helps find overlaps and unique subgroups. Running the cell now. This crosstab shows the count of customers by gender and senior citizen status, with totals included in the margins. Notice the similar distribution between males and females across the two groups, helping us understand demographic composition. This output confirms how categorical columns can be segmented and summarized effectively, which is crucial before deeper analysis or targeted marketing. Try a crosstab of contract type versus churn for deeper segmentation. We create combined segments for more business-relevant groupings. This shows average monthly charges by family segment. Running the cell now. This output shows the average monthly charges for each family segment based on whether customers have a partner and/or dependents. Notice how customers with a partner but no dependents, true/false, have the highest average charges, suggesting family status can influence spending. This demonstrates how creating meaningful demographic segments helps uncover patterns in numeric data linked to customer attributes. Can you create a segmentation using 3 demographic factors? We construct a churn index, percentage of customers churning per contract type. Such segmentation scores are easy to share across teams. Running the cell now. This output shows the churn rate percentage segmented by the type of contract, highlighting a clear trend. Month-to-month customers have the highest churn at 42.7%, while long-term contracts show much lower churn rates. This aligns with the lesson's focus on demographic segmentation, demonstrating how grouping by a relevant categorical column, in this case, contract, can reveal key patterns in customer behavior. Noticing these differences helps businesses target retention efforts effectively. Practice: build an index for any other behavioral outcome. Trend analysis: compare tenure by demographic group to check customer longevity. This helps spot retention issues among certain segments. Running the cell now. This output shows the average tenure for customers segmented by whether they are senior citizens, 0 equals no, 1 equals yes. Notice the values are quite close, 32.2 months for non-seniors and 33.3 months for seniors, indicating that tenure does not vary much between these groups in this dataset. This highlights how grouping by a demographic feature helps us compare key metrics like tenure to understand customer segments better. Which groups tend to stay with the service longest? Let us create a mini end-to-end dataset for segmentation and insight. We simulate 200 customers with random gender, age group, and a net promoter score from 0 to 10. Print to verify structure. Running the cell now. This output shows the first 3 rows of a synthetic customer dataset with 200 entries, including demographic columns, gender, age group, and an NPS score. Notice the mix of categorical data types and numeric scores, which reflects the kind of real-world customer data you'll segment and analyze. This preview confirms the data structure and variety before deeper demographic segmentation. Your turn: try with different age distributions. We average NPS by gender and age group. This shows which demographic clusters are most likely to promote or detract. Running the cell now. This output shows the average NPS score segmented by gender and age group, revealing trends in customer satisfaction across demographics. Notice how the scores vary not only between age groups but also between genders, highlighting the value of multidimensional segmentation. This approach helps identify which specific groups might require targeted marketing or service improvements. Which age and gender segment rates your brand best? Where can you improve? Finally, a very basic insight recommendation is to flag weak segments. If any group rates NPS below 5, alert the business team to act. Running the cell now. This output warns us that at least one demographic segment has a Net Promoter Score, NPS, below 5, indicating low customer satisfaction within that group. The code checks the minimum NPS across all segments to flag weak areas needing attention, emphasizing the importance of examining key statistics by segment to prioritize business actions. Congratulations! You have run a full demographic segmentation from raw data to business action. For more practice, try designing your own segmentation. Watch our YouTube channel for more tutorials.